We are continuing with the specimen paper from 2023 IGCSE Chemistry 0620, paper 1. We had done up to question 10 yesterday. Here's question 11. Which row shows the waste products released from the exhaust of a vehicle powered using a hydrogen oxygen fuel cell? This one should be quick.
A.
Really? It's a hydrogen oxygen fuel cell.
Wait. Yeah, it is. I think it's B1, right?
Well, you can go through all the responses, but
Wait.
why
Okay.
why why why, why don't you let's
Yeah.
take a close look?
E.
Hmm. Okay, since you've gone ABC, it's B. See what happens in a hydrogen oxygen fuel cell. Hydrogen and oxygen are the input; they are the fuel. Thus, the name hydrogen oxygen, right? And they react to form water. And so the only exhaust that is released is water, and that's why the hydrogen oxygen fuel cell is said to be very clean. It doesn't have the pollutants, carbon dioxide and oxides of nitrogen.
Not like carbon dioxide is already present now
In what?
in the air.
Yeah, but yeah, so we're not talking about the air. You
Okay.
are using hydrogen gas and oxygen gas. So where is carbon or nitrogen coming from?
From the environment.
But you're not pumping air into it,
Okay. Mm.
right? If we just go back, I believe, which chapter was it? Was it chemistry of the environment? I forget the chapter. Do you remember the chapter? Atmospheric pollution, catalytic converters. So maybe you're confusing that with catalytic converters. That would have carbon dioxide and oxides of nitrogen. But no, electrochemistry. Fuel cells. Right? A hydrogen oxygen fuel cell uses hydrogen and oxygen to produce electricity, with water as the only substance produced.
Yeah. Okay.
Right? And they've given how that works over here. Okay. Let's zoom out a bit. Which diagram is a correctly labeled reaction pathway diagram for an endothermic reaction? Okay, now you can easily eliminate two of the four options, right? The key is endothermic. So
So
which
endothermic means that it takes in
it
the heat.
it takes in energy. Yes, energy is used up. That would mean that the energy level of the products is what, higher or lower than the reactants?
It would be higher.
Higher, right? And so which two of the four is showing products at a higher energy level?
C and D.
Huh?
C and D.
C and D?
Yeah.
Isn't it A and B?
We are talking about energy reaction.
Energy.
Okay. Yeah.
A and B are showing the products at a higher energy level as compared to the reactants. And so immediately you are eliminating C and D. You don't even want to bother looking at it, right? Now between these two, which one is correctly labeled?
C.
We just eliminated C. Are you guys like sleepy?
No.
You eliminated B and A now.
We eliminated C and D.
You said A and B. Okay.
The energy level of the product is higher than the reactant for endothermic reactions, right? Over here the product has less energy. Energy is on the y-axis,
Yes.
right? And so C and D are eliminated. You're not even looking at them. So between A and B, which is correctly labeled?
A.
B.
Ah, okay. So what's the difference between A and B?
Uh,
Activation.
the overall energy change and the activation
Yeah,
energy.
right. So the overall energy change is taken into consideration when you look at the energy level of the reactants and the products. And so the overall energy change is this arrow over here, right? It is the energy difference between the products and the reactants, right? The activation energy is the total energy required from the level of the reactants all the way to the maximum energy required after which the reaction occurs. So this is right, the slope that's going down, the curve that's going down is after the activation energy has been reached, right? And the reaction actually takes place. So in case of endothermic reactions, right, from the level of the reactant all the way to the peak of the curve is the activation energy.
So it's A.
So it's A, yes. And also make sure when you're asked to draw it, this is obviously given to you, that you make the dotted line, and right, the arrow goes from the dot, touches the dotted line, and it goes all the way and touches the curve, right?
Yeah.
This is for an endothermic reaction. So your answer is A. Now, just since we are here, if they were asking you about an exothermic reaction, right, then what you'd have is something like D. The reactants are at a higher level than the products, right? Energy is lost. The overall energy change is again between the level of the reactants and the products, but then the, but then it's like, what about the bump? And so that bump is just the activation energy. So obviously the activation energy is less in exothermic reactions. We just need to provide some more energy as compared to what the reactants already had to get the reaction going. And so the reaction is right. And so this fall, right, is all the energy that is being given off, thus being exothermic, right? So if it were an exothermic reaction, B is exactly what you'd have,
Okay.
right? But obviously
Yeah.
for this question, A is the correct response. Oops.
Okay.
Okay. Oh, we missed one. Question 13. Okay. Which changes are physical changes?
Uh, wait. 1 and 4.
Second.
B?
Yeah.
Yeah.
Yes. Good. Right, because adding sodium to water is going to cause a reaction, and burning of hydrogen to form water is also a chemical reaction. So those are chemical changes,
Okay.
right? Do not mistake this. You need to be. It just occurred to me, maybe some student would have seen adding sodium to water and they would have gone for some reason mistaken sodium to be sodium chloride, although it's not written that way, and they would have like, oh, adding this to water means it's dissolving. No, sodium doesn't dissolve in water. It reacts to form sodium, right, to give off hydrogen gas and to form a salt.
Yeah.
Okay. The diagram shows an experiment to measure the rate of a chemical reaction. So if you got a metal, you're adding dilute hydrochloric acid to it, right? And so what gas are you going to get from this? You can see obviously that a gas is being produced. Hmm?
Sorry, repeat that.
Mm.
I mean, this is not the question, but I'm asking you, right? There's a piece of metal in the conical flask, and you're adding dilute hydrochloric acid to it. And you can obviously see in this part, right, there's a tube going into a measuring cylinder, inverted measuring cylinder. There's water, and you can see bubbles. So there's obviously a gas being produced. What's the gas being produced?
Mm, wait. Chloride.
How can you say chloride? Because it's hydrochloric?
Yeah.
Well, you don't just get chlorine gas out of nothing. Right now over here, I want to point out that you need to know the very basics of reactions, right? So metal plus acid will give you what? So it will give you,
Metal chloride.
yes, it will give you a metal chloride, and it will give you hydrogen gas,
Okay.
right? Again, if we go to chapter, I believe metals, right? So you've got reaction of metals with, no, okay, it's in acids and bases then. Yeah, acid plus metal gives you salt plus hydrogen. So magnesium plus hydrochloric acid gives you magnesium chloride and hydrogen gas. Right? Now, without going into the specifics of what metal and what acid it is, you need to know this. Right? If they're telling you it's an acid and a metal, you need to know it's going to form a salt and it's going to form hydrogen gas. So when I look at this, I'm like, oh, right now, again, I just asked you that to sort of revise your concept, even though that's not the question. They're not asking you which gas is being produced. So the question is, the diagram shows an experiment to measure the rate of a chemical reaction, right? Which changes decrease the rate. So what will you change over here that will decrease the rate of the reaction? Adding water to the flask, heating the flask, using more concentrated acid, or using powdered metal. What will cause a decrease in the rate of reaction?
A.
Why?
D.
Because the water will slow the rate of reaction down.
Yeah, but why would it do that?
Because of wait. So am I wrong? Am I at the wrong side or am I at the correct side?
Well, you would obviously have a reason for choosing a specific answer, right? Or are you like going
Gut.
in? Yeah, okay, fine. Gut, right? Haram, you say
D.
D,
Yeah.
the last one.
Yes.
Okay, why?
Because like its property changes and
What property changes?
not exactly properties, but when we're reacting with like hydrochloric acid, it will obviously like
Okay, now
Can
remember,
I say? Acha, I just Remember? Can I also add another reason?
Just a sec.
Okay.
So, Haram, remember when we were talking about, again, I forget exactly which chapters those are, but uh, I don't know, one of the chapters where we talked about uh, the effect of surface area on the rate of reaction,
Yeah.
right? And so increasing the surface area in of a solid increases the rate of reaction. So if you're using
Yeah.
powdered metal, a powdered metal would have more surface area as compared to a strip of metal. And so there's more surface area for the reaction, which will increase the rate of reaction. So that would be the incorrect choice, right? They're asking for a decrease. Now, Sobia, what is your reasoning?
Because it dilutes the water, dilutes the, what do you call?
The acid?
Yeah,
Yeah, but the water's here.
that's the metal there, right?
Yeah, so you're adding water to the flask.
The hydrochloric acid also comes down, so wouldn't it dilute?
Now, see, if like if I understand the question correctly, the answer is A, by the way,
Yeah,
right? The answer is A. Uh, but if I understand this correctly, what could the reason be? So if they already have water and they put the metal in the water, so we just saw that the metal will react with water itself. And so, right, either like if it's not one of those let's say very reactive metals like sodium, right, that will react with the water as soon as it comes into contact with it. For example, it's like a less reactive metal. What would happen is, right, the water and the air, it will immediately form a coating. The corrosion that we learned about metals,
yeah,
for corrosion to happen, you need water and air. And so the metal will react with the water and the dissolved oxygen. There's air in the flask, and so there'll be a coating, right? That could be a reasoning, but then it could be argued that okay, it's not going to happen immediately, so right, maybe that doesn't work. Another reasoning, if it's a reactive metal, right, then the metal will react with the water, and so there'll be less of the metal available for the hydrochloric acid to react. The third reasoning is okay, fine, like what you said. If it's not like a very reactive metal, so if there's water in it, when you're dropping the dilute hydrochloric acid, there's water in the flask, it will become further dilute,
yeah,
right? And so, right, there's less of the acid molecules in the volume comparatively, and like it's more spaced out, and so the reaction will slow because there are lesser acid molecules reacting with the metal in that volume. It will take more time, and so the rate will decrease. It will happen, but it will just slow down.
yeah,
Okay,
yeah,
so obviously we don't know which metal it is, so right, but for any of those three, and simply, right, simply saying, right, you could argue, well, sir, we don't know which three of the explanations is true. Okay, heating, generally, unless it's an endothermic reaction, uh,
wouldn't the particles gain kinetic energy?
well, exactly, right, so heating will increase the rate of reaction,
Yeah,
right? Using concentrated acid means there's more hydrogen ions. Remember the difference between right, sorry, per unit volume. So the concentrated acid means there's more acid molecules in that volume. And so if there's
Yes.
more acid molecules, that means it has more protons available, which means it will speed up. And I already explained
Yeah.
D. So each of these three options will result in an increase in the rate of reaction. So if you went that way as well, automatically by elimination, we're like, well, three of the four are wrong. So let's just go with this.
yeah,
Okay.
Yeah.
But again, you need reasoning for that. Like, why are they wrong? Obviously. Okay, question 15. Which row describes the effect of increasing concentration and increasing temperature on the collision between reacting particles?
C and D are incorrect.
Okay.
It's not C and D. B and D.
B and D.
No, C and D.
Okay, so C says for increasing concentration, more collisions per second and more collisions with sufficient energy. Right, so I believe that you are saying that they're incorrect because for concentration, they're saying that the collisions will have sufficient energy.
Yes.
Right, so you immediately remove C and D. Right, and I would say that your approach is correct. Unless, Phobia, you were considering C and D?
I was considering D.
D?
D, D.
Well, you see that the option for D is the same for both. So increasing concentration, increasing temperature has the same effect.
Well, I'm going for that.
Okay, so what if I say Haram's elimination is correct? You remove C and D, they're both incorrect.
Well, that's unfortunate.
Then which one would you go for?
Uh, Wait. I would go for B.
Haram?
Mm, mhm.
Okay, another way to eliminate this, your approach was correct, by the way, that single change does not affect both,
Yes.
right? You could have also eliminated B and A, right? So increasing concentration only increases the collisions per second, and increasing temperature also only increases collision per second, right? So even though that factor is there for increasing temperature, temperature does increase the collision per second, but that's not the only thing it does. So increasing concentration means you have more molecules per unit volume. And if you've got more molecules per unit volume, you have more collisions per second, because it's like having 3 people in a room and then having 10 people in a room, right? So you've got more people in that, so you're probably going to talk or interact with more people, right? So that's correct. And
Increasing temperature increases like internal energy, na?
internal energy, and so increases the kinetic energy, and so, right, not only are the number of collisions increasing, but the collisions themselves will have sufficient energy to react, so you'll have more successful collisions,
Yes.
right? And so B is the correct answer. Good.
Okay.
All right. Methanol is prepared by the reversible reaction shown. So you've got carbon monoxide reacting with hydrogen to give you methanol, right? The forward reaction is exothermic. Which conditions produce the highest equilibrium yield of methanol? Temperature and pressure.
Temperature, like energy is released. Is it?
So exothermic reactions release energy. And so what we learned about equilibria, when there's an exothermic reaction, would a high temperature favor forming the product or a low temperature favor forming the product?
C.
Okay.
A?
No, no. First answer my question.
Low.
For an exothermic reaction, what would favor forming the product? A high temperature or a low temperature?
Temperature.
Huh?
High temperature.
No. Exothermic reaction means that it is giving off energy, meaning that the reactant is, right. So you want to keep the temperature low so that the exothermic can happen. If,
Yeah.
right, that means that the reverse is endothermic, right? Going, because it's reversible, that methanol will break up into carbon monoxide and hydrogen, and that takes in energy. So if you're keeping a high temperature, you are providing energy. So that means you are actually promoting the reactants to stay as they are, because energy is being provided, right? So to promote an exothermic reaction, you need lower temperatures. So if you're choosing low, A and B are automatically eliminated.
So like equilibrium means the temperature and pressure would be equal.
Huh?
Equilibrium means the temperature and pressure would be
No,
equal.
equilibrium would mean that the rate of forward reaction is equal to the rate of reverse reaction. That is what equilibrium means,
Okay.
right? So you've chosen low temperature, right? Now what about pressure?
Pressure would be low automatically.
Why automatically?
Because in like Boyle's law, uh,
Oh,
it
wait,
says
no, 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 no. You can
okay.
you can alter pressure with volume as well. Remember?
Yes.
So you can cause pressure to increase without changing. You can keep the temperature constant. So
Yeah.
now considering that, right, would you have high pressure or low pressure?
High.
Right. Again, right, equilibrium told us that for gases, right, uh, increasing the pressure will uh, favor the reaction which has lesser number of molecules. So does the reactant have lesser number of molecules or the product? Hello?
Reactant.
Both are reactive.
Both are the same.
No.
Which side has lesser number of molecules?
Reactant.
No. One molecule of carbon monoxide, two molecules of hydrogen gas, that's three molecules.
Right side.
Right? The product has only one molecule. We're not looking at the size of the molecule, we're just looking at the number of molecules.
Yeah.
Right? So the product side has less number of molecules, and so high pressure will favor formation of more product. Low temperature will favor formation of more product. Right? And so the best combination is low temperature, high pressure. That's C. Understand, Haran? Okay. Question 17. When chlorine gas dissolves in water, a reaction occurs. Okay, which row of the table identifies the oxidation number of chlorine in the chlorine containing species? This one is slightly tricky, but I don't want to.
Oxidation means
Oxidation number meaning it's gaining or losing electrons.
okay.
I mean, not gaining or losing electrons in the sense, uh, right? This is HCl is covalent primarily, right? So, I mean, it is like, is it the one sharing electrons in case of covalent, or is it the one receiving the sharing of electrons, right? Or what's going on? So, oxidation number, to revisit that, okay, periodic table.
It's in bonding and structure.
It's in bonding and structure. Yeah, this is the problem I'm having, recalling exactly which chapter has that bit of information. It's obviously here. Oxidation number. Each atom of an element or compound is assigned an oxidation number to show how much it is reduced or oxidized. And again, reduced and oxidized, right, means either gaining oxygen, losing, like oxidation is either gaining oxygen, losing hydrogen, or losing an electron, and reduction is losing oxygen, gaining hydrogen, or gaining an electron, right? Or oxidation is an increase in oxidation number, and reduction is a decrease in oxidation number. So the numbers, if the numbers going up positively, that's oxidation. If the numbers coming down, right, from positive to less positive or going into negative, that's a reduction. So how much it is oxidized or reduced. So over here, which of these is telling you how much, like, for example, 0 means that it is neither oxidized or reduced. So for Cl2, can we agree that the oxidation number is going to be 0?
Yeah,
No,
We can't agree on that?
I
it would
agree.
be -1.
Huh?
It would be -1.
No. It's elemental chlorine. Elemental chlorine is neither oxidized nor reduced. It is in its elemental state, just as it wants to be. Right? So it is,
Okay.
right? So that's 0. Okay? Ele- Elements in their elemental state have 0 oxidation or reduction. Right? So Cl2 is diatomic naturally, right? Its oxidation state is 0, right? So we can agree on that. And because of that, you're automatically eliminating options A and C. You only have options B and D left.
Yeah,
Right now, both of them for HCl are saying that chlorine is -1, right? Meaning it has been reduced, which makes sense, right? Chlorine has gained a hydrogen,
yeah,
right? And it's in group 7, it needs one electron, which it's sharing in this case because it's ion covalent. It's sharing that electron from hydrogen, and it's sharing its own with hydrogen as well. And so it's chlorine is -1, hydrogen is +1, right? But you're not asking about hydrogen. So chlorine is -1. So still both B and D are correct. Now it comes to HClO. What is the oxidation number of chlorine in HClO?
in HClO, hydrogen um has +1 and oxygen has -2.
Yes. Yes. Good. Keep going.
Uh, so that would be, wait, that would be D.
It would be D. It would be D. Now, why, but why +1?
Because that loses, uh, oxygen loses 2 electrons.
Okay, so right, for a molecule, right, a molecule, if it's stable, right, after reaction, it should be electrically neutral. And so the molecule overall uh, should have like a total oxidation state of 0. The molecule. So HClO should have an oxidation number, an oxidation state of 0, right? We know hydrogen is +1, right? We know oxygen is -2, sorry,
Yeah,
-2, right? So what does that leave us with to balance it out and make it 0?
that will leave us with -1.
+1,
Yeah, okay.
right? Does this make sense?
Yes,
We know hydrogen is +1.
yes, yes.
We know oxygen is -2.
Yeah.
right? So plus 1 minus 2 gives you minus 1. So if we are, right, we still have minus 1 left. So how will we counter the minus 1 and bring the total to 0? Only if chlorine has an oxidation number of plus 1. Okay?
Okay.
Okay. Hoping that made sense. Right. Moving on to question 18. Four different solutions, J, K, L, and M, are tested with universal indicator. Right? Color the solutions and the color with universal indicator. One's going green, the other's going red, purple, and orange. Which one of these are acidic? So
J and L.
this tells you that you need to know this information, right? You need to know the colors of the indicators that are given to you in your syllabus in acidic and alkaline conditions.
Yeah. Okay. B.
I'm like confused between B and C.
Okay, you're confused between B and C, right?
Yes.
So either it's only red or it's red and orange. Now, in this
Yes.
case, what is your gut saying?
K.
Only K?
Yes.
And Sobia, you're saying B.
Yeah.
It is B, right? So if we go to acids, bases, and salts,
Wait. There is one thing that it says solutions. If it was singular, then I think it would have gone with K. But since it's plural, I think we should. It's K and M.
that could be a hint. That could be a hint because the question is asking for a plural. Then you'd go like they're asking for, but then right, you I mean you even for the plural, are you going to go for GMN or KMN? And so knowing the color changes is important, right? And so that's given over here, the beginning of the chapter. And so you got uh, pink for methyl orange, right? And colorless over here for thymophila. It's not really helping, is it? Red and orange. So pink.
No.
Hmm. Wait. Question again. Universal indicator. Sorry, universal indicator. Okay, sorry, my bad. So this is the universal indicator, right? And so the color range, all red, orange, right, all the way up till here, right, is acidic. Well, not 7 actually, up till 6, right? So yeah. So knowing that color range would help.
Yeah.
Okay. Which solution, question 19, which solution has the lowest pH? Lowest pH meaning it is most acidic.
Mm,
Which of these is most,
C.
huh?
C or D.
C or B?
B. D.
D. How can lithium hydroxide be acidic, beta?
it's the lithium hydroxide has a strong base.
Yeah, right. Low pH meaning the lower numbers, and the lower numbers are acidic,
Yes.
right? So ammonia solution is alkaline lithium hydroxide because they're saying solution, and so lithium hydroxide is also alkaline. So it's
Yeah.
either ethanoic acid or hydrochloric acid. Now over here it will come down to, oh, we know hydrochloric acid is a strong acid, ethanoic acid is a weak acid, right? And
Yeah.
strong and weak acids means that, uh, right, how many protons do they have available? So hydrochloric acid is a strong acid, has more protons available, and pH is a measure of how many protons are available, right?
Yeah.
Ethanoic acid has less protons available, and so that's a weak acid. So the lowest pH means which one of these is the strongest acid. So between B and C, because you don't like eliminate A and D immediately, and so C is the answer.
Yeah.
All right, 20. Magnesium, calcium, strontium, and barium group 2 elements. Group 2 elements follow the same trends in reactivity as group 1 elements, right? Which statement about group 2 elements are correct? Right? Calcium reacts faster than magnesium with water. Barium reacts less vigorously than magnesium with dilute acid. Strontium oxidizes in air more slowly than barium. Now, since we have the periodic table, right? Group 2, and we have magnesium over here at the top, then we have calcium, and then we have strontium, right? So these are the three we're talking about, right? Now, trends for reactivity. Does reactivity increase or decrease down the group?
Increase.
It increases down the group, right? So, will calcium react faster than magnesium?
Yes.
Yes, right?
C. No wait. Yes, C is the answer.
It is.
Yeah.
It is the answer.
Okay.
Yeah. Oh, there's right, barium as well, right? So barium would be the most reactive, right? And so saying barium reacts less vigorously than magnesium, barium is the most reactive of these guys, so it will react most vigorously with dilute acid, right? So that eliminates two. And so strontium oxidizes in air more slowly. Yes, compared to barium, strontium will be slow, and so that's 1 and 3. Okay. Uh, you guys want to try a few more? I mean, I do have class, so
We can try the last one, just 21.
21. Okay. Chlorine, bromine, and iodine are elements in group 7 of the periodic table. Which statement about these elements is correct?
They are non-metal.
They're all non-metals. Yes. They are all gases at room temperature and pressure. That's not true. The density decreases. No, it's increasing down the group. The color gets lighter. No, the color is getting darker down the group.
Yes.
Right? So they're all non-metals. That's easy. Let's do another.
Oh god.
Yes. Which row describes the properties of a typical transition metal, transition element?
Mm.
You pick any transition element, what will you see?
Can you give an example of a
C.
transition element?
Iron, vanadium, like all of these guys in between, right? All of these guys, you've got tin, you've got vanadium, chromium, manganese, iron, cobalt, nickel, copper, right? Palladium, lead. Those, no, you don't have lead here. Lead is, where is lead? PB, right?
Okay.
Why can't I find lead?
Lead decided to disappear.
Oh, here it is. Yeah. Anyway, lead's not a transition metal. Gold is a transition metal, platinum is a transition metal, silver is a transition metal, right? Iridium and all of those guys. So, yes, what would be the properties of a typical transition element?
See.
You're saying that
They,
it, uh-huh.
no,
No, no, go ahead.
they have a high melting point.
Yes. So that would, like, for you, that would give you options A and B.
Yes.
Which one will you go for?
Uh, they cannot like act as a catalyst
They
because
cannot.
iron. Um, if I'm taking the example of iron,
No,
then
no, it's a typical transition element. So any
okay,
like generally,
then it be B.
right? So we are saying C.
Mm-hmm.
Okay, so yours would be incorrect. So Haram's is correct because transition metals have higher melting points, right? They have generally variable oxidation numbers: iron 2, iron 3, copper 1, copper 2, right? Manganese 7, manganese 2, manganese, like all of those. So they have variable oxidation numbers, right? And they can be used as catalysts, right? You've got nickel, you've got vanadium, right? All of these are used as catalysts, so yes. Okay, finally, question 23.
Sir.
Just like really the last one, right? Which statement about the noble gases is correct?
D.
The noble gases are
Not
found
D.
on the left side of the periodic table.
No, no, no. No.
C.
They are not diatomic.
No, they're not.
Neither, neither they are reactive.
No, they're
It's
not.
C.
It is C.
So C.
Yes. And by the way, just by saying that it's on the left or right hand side is not a very specific statement. Oh, it's towards the left, it's towards the right. Like what group?
It's in the middle.
No, it's not. It's towards the extreme right, if you want to say that, but it's in group of both, right?
I got confused between right and left. That's why.
Yes. So your left is your left, and your right is your right. Okay. Right. So yes, right. C is the answer. Let's do 24 then.
सर ऐसे तो फिर सारे कर लेते.
Okay.
It's A.
Okay. So yes, it is A actually, right? I'm guessing you recently had a test or something,
I didn't. I
right?
had a test in school.
Yes, so yeah, right. Not all metals are hard, not all metals have low melting points, and not all metals react with water, but all metals do conduct electricity. So yes. Okay, we'll stop
Yes.
here, right? So thanks to Haram, we've done 20 up till 24. Uh, right, we can keep going. Unfortunately, I have a class. As much as at least I was enjoying this, I hope you like it was fruitful,
Yeah. Yeah.
right? So we'll continue this next time. Hopefully, we'll wrap this up the next time, and then we can move
How
on.
many questions are there?
40 in total, so there's 16 left.
Okay.
Okay, so just try to be a bit more punctual. We can start on time, and so we can definitely wrap this up next class. I don't want it to carry on for two further classes, one class at most, and then we can take a look at paper two.
Okay.
Yeah.
Okay,
Okay.
all right, next time, inshallah.
Inshallah. Allah Hafiz.
Allah Hafiz.